Hi friends, welcome back. Today we're talking about the distance formula, and before we dive into the formula itself, I kind of want to show you how it works here. So let's say that I have these 2 points, -2 and -2 comma 3 and 4 comma -5. And I want to find the distance between these 2 points. Let's see if I can draw this line nice and straight towards that other point. I want to find the distance between those 2 points. Well, what we can do is draw ourselves a right triangle, because if you remember, with a right triangle, we can use Pythagorean Theorem, which is to say a squared plus b squared equals c squared. All right, so let's do some counting here. We have 2, 4, 6 over here, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. All right, so I have my legs on my right triangle are 6 and 8. So we're going to say 6 squared plus 8 squared equals c squared. 6 squared is 36 plus 8, which is 64, equals c squared. 36 plus 64 is going to give us 100. So we have 100 equals c squared. Now, to get that c by itself, the opposite of squaring something is to square root it. So I get c equals 10. All right, so I have found my distance between these 2 points. Now, it's not always helpful to be able to graph it. Maybe you're given really big points, or you're given things that are very far away. So what we have is a distance formula based upon this Pythagorean theorem. And all we're doing is we're taking this c squared over here. So a squared plus b squared equals c squared. We're square rooting both sides. So we're finding our a, remember, is the length of our side, and our b is the length of our side. Now, how do we find the length of our side when we are on the coordinate plane? We take our points and we subtract them from each other. Now, it's vitally important that you go in order, as far as if you choose your y2 first, you have to choose your x2 first. You may see this written differently, where your x's are in front or your y's are and your y's are in back. That's fine as well. So let's go ahead and give this guy a shot. If you have not already, grab your notebook, make sure that you write down this distance formula, pause the video if you need to, and make sure that you have that guy. All right, so this is our point. We have x1, y1, x2, y2. So we're gonna say the distance equals the square root of y2, which is -5, minus y1, which is -8 squared, plus -8 minus -5 squared. All right, I always like to add the opposite. So add the opposite, add the opposite. So what that means is we have over here 3 squared plus, and now over here we have -3 squared. Don't forget to put it in parentheses, because that means something very different if you don't. If you don't put it in parentheses, it would be a -9. So both of these are 9. So we get d equals 9 plus 9. Now I'm gonna make sure that I have enough room here. So we have d equals 18. And in a previous lesson, we revisited how to simplify our radicals. I see a perfect square that's hidden in there, and that one is 9. So we say d equals √9 √2, because the square root of 9 times the square root of 2 would give us the square root of 18. Square root of 9 is 3, so our d equals 3 √2. So the distance between these 2 points would be 3 times √2. Let's try that again for this one. So x1, y1, x2, y2. Okay, so we're going to say the distance equals y2 is -4 minus our y1, which is -2 squared, plus our x2, which is -3 minus 1, which is our x1. And I stayed in order there. That's vitally important. Let's add the opposite, add the opposite. So in this case, I get d equals the square root of -2 squared plus, and again, if you have that negative, you have to use those parentheses. Otherwise, you get something very different. And then -4 squared. All right, so quantity, or parentheses, -2 squared gives us 4. So 4 plus 16 gives us the square root of 20. I'm going to move this over here so we can see. So we have the distance equals the square root of 20. That is not your final answer, because you always want to ask yourself, hey, can I simplify this further? And we do have a perfect square hidden in here, and that is 4. √4 √5. The square root of 4 is 2. So we have our distance is 2 √5 between these 2 points. Hopefully that helps, and I look forward to seeing you next time.